Hello everyone. Now this particular video number 3.1 is uploading. About 50-60% has been uploaded. Next, I'm making one more video 3.2 in which I will explain you how you as a viewer of this video you can submit questions to my exam. Okay, so how to do that? Okay, so far we have, if you have been seeing my playlist, so the playlist is about creating customized exam paper, and we have from 1.1 onwards we have seen several videos to finally come up to the video 3.1 where we created a question, parameterized it, and also given solutions to it. Now how you can submit a question. Okay, so let's look at it. So it is very simple, you don't have to do any coding, but you need to submit the question into this question bank. See, right now, the question bank has three LaTeX files, that is three questions, and three parameter files, that is JSON objects. So, if you want to submit a question, you have to submit two files. So, one file is text file describing the question and also the solution with parameters. Another file is the JSON object with the parameters and its values. So this is what is expected from your side. So how do you submit the questions? Very simple. You submit by filling a Google form. Okay. So I will show you a live demo of it. So let's go back to my exam sections. So as you have seen, AC has one question and DC circuits has two questions, whereas induction motors has no questions and transformer also has no questions. So let's look at induction motor and let's try to add one question into induction motor. Okay, so just to remind, what is the question, I can just go back to the first demo exam which I created. So meanwhile, let me yeah, so this is the demo exam which I created first. So under induction motor, so I have simple questions like this. Calculate the full load slip of the motor. So slip calculation question. So let's create this question. So I copy this. So what you have to do is you decide on a concept. What concept I want to make a question on. I'll give you the list of concepts also shortly, but you decide a concept, you identify the question, and then copy the question, and then go to Notepad, and then you can format the question in the form of a LaTeX file. Okay, so how do I do that? Question: a three-phase, six-pole induction motor runs at 960 RPM. Okay, at full load. It is supplied from four-pole alternator. So this looks like a trick question. Running at 1500 RPM, calculate the full load slip of the motor. See, this is a trick question. As long as the motor is concerned, the P is given and the N is given, but of course the frequency is not given. So to find the frequency, we need to uh, look at the alternator. Okay, so in this, that is a twist in this question. Anyway, I think let's not worry about that. Let's remove this part. Let's simplify the question. Three phase, 200 volts, 50 hertz, six pole induction motor runs at 960 RPM at full load. Calculate the full load slip of the motor. So it's a very simple question. All right. So this is the question. For example, you decided that you want to ask this question. So what do you do next? Let's save this file. Somewhere you save it. Okay, so you save it. In my example, I'm just directly saving it uh, in the question bank itself. I'm calling it slip.txt. Okay, so because it is about question about calculation of slip. Now, not only this, I will parameterize this. So the voltage doesn't matter, whatever voltage it is there, because to calculate slip, it doesn't depend on the voltage. It depends on the NR and frequency and poles. Okay. Now frequency dash dash f dash dash. So I am parameterizing the frequency value. Poles also dash dash, or let's keep poles as 6. and then or let's make it poles as P and then NR. See, but problem is the rotor speed. Usually, the full load slip will be around 5%, 6%, 7%, 10%, something like that. So we need to properly choose the values such that I get the slip in this value. So I will let me also add answer line, and after answer line, let me add the solution also. Begin solution, end solution, and here I will create the solution. So the solution is is nothing but, so first of all I have to calculate the synchronous speed. Synchronous speed dollar n underscore s equal to 120 into f divided by p. So which equal to 120 into dash dash f dash dash divided by dash dash p dash dash. Okay, so like this. Then here it will be in RPM. Then slip S equal to ns minus nr divided by ns, which equal to, now I need one parameter to store the ns value, so that we will take care. Ns divided, I'll just simply repeat that, minus nr divided by ns. So again, I need a solution to store my slip value. So here slip will be in decimal. So that is equal to slip in percentage, SP backslash percentage. So now I have the entire solution also ready. Okay, just two line solution simply. Now I go to my parameters file. So let's go to the parameters file. Let's duplicate this. So what are my parameters? So first is the frequency and poles. Okay, so let's write F and P. So obviously P cannot be, the number of poles cannot be what you call odd number. So frequency also usually it is 50. So but let's take it as 30 to 70 in steps of 10. Okay, so no country uses 30 hertz, but just for sake of argument. Okay. So 40, 70, 30, 40, 60, 40, 50, 30. So randomly frequency values are coming here. Similarly, the minimum value of poles. Okay, let's start with 2 poles. We'll go all the way up to 14 poles. Okay, so in the steps of 2. Okay. So sometimes 12 poles, sometimes 2 poles, sometimes 12, 14, something like this. Now I want to simply calculate the value of ns. Okay, so what is ns? So here this whole things I will delete. So what is ns? 120 multiplied by f divided by p. 120 f by p. So this I will round off to nearest this integer. Okay, some places the synchronous speed is also in fraction. How is that possible? 60 into, okay, 120 into f divided by p. Okay, so because 120 into 60 divided by 14. Is that correct? 120 into. Sometimes it may come in fraction, that is okay. So let's round it off to integer. So now I have synchronous speed. Next, now I want to do back calculation actually. So slip, I want to get slip somewhere between 3 to 10%, okay, in the steps of 1. Okay. So in order to get slip of 4%, 7%, whatever, or I will say 0.03 to 0.1 in the steps of 0.01%. Okay. So this is the slip. So now I will calculate NR. Okay. So NR equal to NS into 1 minus slip. Okay, that's another formula. So E6 into 1 minus E. Okay. So let's allow one decimal. I think the problem is with wherever there is a, uh, 1 second. Okay, wherever there is a 14 poles, I think there is a problem coming. So I'll avoid using 14 poles. I will just go for 12 poles. So now everything is all right. Looks like everything is this thing. So so I have avoided using 14 poles. So this is just the aspect of designing your proper exam. So this I will round off to nearest integer. Okay, so now I got NS and NR. Okay, everything is fine. Slip is also there. So that's it. So now I have what else is needed? NS, NR, FP. Okay, slip and SP. Slip in percentage. Okay, so SP. Slip in percentage will be nothing but whatever is the slip multiplied by 100. So this will be slip in percentage, and then this percentage slip also I will round off to the nearest integer. Okay, so that's it. So here I can close this brackets. So I don't need all these three columns. So just like how we have done for other things, so all this exercise you are supposed to do, okay, in order to submit the question. Now go to a new file. I'll just take a new file from Notepad. Here I paste it, and then I'll do the usual replacements. So what are the replacements? Control C, Control H, and this part will be replaced with open bracket and comma. Replace all. Next, this part, Control C, Control H. This part will be replaced only with open bracket. Then this tab will be replaced with a comma. Now what are these? These are values. So let me say values, and then I'll open a square bracket and remove the comma in the end and close it. Then I close it with a flower bracket, and here I'll open it with a flower bracket. Before that, parameters. Again, the order doesn't matter because we are using find and replace kind of thing. So the parameters that we have are these. F, comma, P, comma, NS, comma, NR, and SP. Okay, so now this file is complete. So let's save this. So definitely I have to give the same file name as I did for the other this one slip.txt. So this will be slip.json. So I'm saving it in the same file. Okay. So next what you can do is I'll give you a link. Okay. So I'll close all these files. I have just created one Google form. Okay. So this is a Google form. So in this Google form, basically it will be question submission form. Okay. So you can just give your name. So let's say I give my name Pradeep. I'm sorry, this is email. Now here this is important. Choose the concept which is tested in the question. So I have listed DC1, DC2. These are concepts. Okay. So 30 concepts under DC. Okay. Then under AC subject, I have listed 30 concepts. So 30 plus 30, 60 questions are done. Under transformers, I have given 25 concepts. So 60 plus 25 is 85. The remaining 15 concepts I have given from the induction motor. So, and therefore, total we have 100 concepts. Okay, so I am requesting the people to submit questions on these concepts. Therefore, the 100 concepts, if I get all the questions, then I can complete the question paper, I can give to the students. Now, for the students who are registered to my course, EE1102, students can also submit the questions. Okay, so that if you submit the questions, but I restrict only two questions per student. Of course, you can submit five questions, seven questions, but I will take only two questions from each email ID of my registered students, so that those two questions I will incorporate into the question bank. Therefore, tomorrow you may get that question if the computer randomly chooses that question for you. So it is an advantage. So again, I request all my students to look at this list of concepts. I will separately send an email to my students also. You study this concept, okay, and then so for example, 2 watt meter power measurement in three phase circuit. You study that concept, either look my own videos or look at somebody else's videos on YouTube. You learn that concept, you prepare a question on that concept, prepare some parameters, generate some solutions, and then submit your question on this concept of AC20. I will incorporate that into the exam, and tomorrow in your exam you may get that question. So therefore, it will be easy for you to solve. So I have more than 150 students, close to 160 students. If each of you submit two questions, I will get 320 questions. I will myself make at least 200 questions myself. So the question bank will be big, and randomly we will choose questions from it to create a variety of question papers customized to each student. So it is beneficial for students to submit. So anyway, what was our question? Our question was in induction motors about creating or about finding the slips. Okay? Finding slip using S equal to Ns minus Nr. Okay? So this one. On that concept, now I can add a file. Okay, so select files from your device. So I'll go to question bank. Of course, ultimately it has to come back to question bank, but for demo I'm showing. So one file you upload, okay, that is the text file here. Then upload parameters file in .json format. So another file you upload, that will be slip.json. Okay, so make sure that your files are error free, and then you upload these two files, and then you can say thank you. Please include this in the final exam. So then you may get that. So then I can simply submit the form. Okay? So when I submit this form, I will be receiving this question. So anywhere in the world, see, thanks, your question has been received. It will be verified, and if found correct, it will be included into the question bank of basic electrical engineering exam. Best wishes. So if you students submit your question, and it may come in your exam tomorrow. But again, as I said, I will allow only two questions per email ID which is registered to my course. Okay, so you can work on that. Now, on the receiving end, what I will get is I think is this the question? So I think these are the questions which got uploaded, and I can also look at the form responses and then create new spreadsheet. I can go to my responses sheet, and then I can the timestamp is there, email ID is there, and then the question will be coming in that particular drive. Okay, so I'm asking all my 17,000 plus subscribers also. If you are following my videos, try to create some questions and help me in conducting exam to my students. You can submit, at least one or two questions on this. Anyway, so the link to this particular form, I will leave it in the description of this video. So you can go to description box, you will find the link. Using that link, you can submit your questions. Okay, now on the other hand, why if I come back, what else I have to do? I have to just go to this particular. See, already question bank has the questions. I just go to. I'll just copy one of the file, and then I'll just throw it inside the induction motors, and then I'll edit it, and then here slip I will keep so that. And what is the concept? Okay, so let me correctly choose the concept. So this is actual list of concepts. So finding slip using this is the concept. IM4 is the concept ID. So this is for my reference. So if more questions I get, I will keep adding more questions to this particular list of questions. So randomly your question may get selected into it. Okay, so that is also there. Okay, so let's go back to my exam. Let's run this and hope that that new question will be created. So let's see. This question should appear under the induction motors section. Okay, so there is it. So a three-phase 200 volt 40 hertz 10 pole induction motor runs at 461 rpm at full load. Calculate the full load slip of the motor. Okay, so if it is 40 hertz, so 120 into 40 divided by 10. So 120 into 4, 480. 480, 461. So 480 minus 461. What is that? 480 minus 461. So 19, okay, and 19 divided by 480. Okay, I'm just solving the question. So about 4% is the slip. Okay, so correct answer is 4% slip. Okay, so that is how we should solve this particular question. Anyway, so I think now you got the idea, the full cycle we have created, how to create customized exam, how to create a data of question banks, so and so on like that. See, my vision, my idea. See, right now in the question bank we have one, two, three, four questions, but at least I want to have 4,000 questions or even 10,000 questions in the question bank, so that over the next couple of years or 2 3 years, then the exam will be really rich and anybody doing this course. So now it is open for my students, but then later in future I will open the exam for anybody in the world to just register, download the question paper, solve it and upload your answers. I will give you a certificate that you have completed this course. You need not be student of IIT Hyderabad. You can be anywhere in any country. I will give you a certificate saying that if you cross maybe 80%, 90% marks, I give you a certificate saying that you have completed the particular course. Okay, so I think I will not take much more time. Thanks for listening to the entire playlist patiently. So this is the list. Thanks for listening to the entire playlist patiently, and thanks for practicing it, and much more thanks for uploading your questions. I'm expecting starting today, tomorrow you will start uploading questions. I think even I'll be working in next 2 3 days. I want to finish 100 questions. 30 from DC, 30 from AC, 15, 25 from transformer, and 15 from induction motor to create this thing. But only I creating the questions will not be good. I have 17,000 plus subscribers. I'm requesting each of you to create at least one or two questions, and you can upload using the Google Form link, which is there in the description. Thank you. Please like my video. Please subscribe to my channel, and see you later with more interesting videos related to electrical engineering and coding and software and etc. Thank you so much.